Torque is all about Newton's third law of physics. For every action, there's an equal and positive reaction. When you're using a hand clicker wrench, such as this, you're the reaction point. When you're using one of our tools, we have what we call a reaction bar or reaction cup. This is the nut that you're either tightening or loosening. This is the reaction cup against the adjacent nut. We've got this spaced so you can work on the mains, you can work on the heads, you can work on a CAT engine, you can work on a Mac engine, you can work on an international engine by changing sockets and using the same reaction bar. This tool has an operating range of 150 foot-pounds to about 950 foot-pounds. You can use it just as well for breaking out as you can for setting torque. And it'll fit on the mains and on the heads without any obstructions. So what we're doing here, we put it on here. We're gonna loosen it first. Now they're all loose. How long would that have taken your guys to do it, laying under the truck, 2 guys on the back? Quite a bit longer than it took me. You hear it's got a high pitch to it. It's under 80 decibels. If you got a couple of these guns running, noise becomes a factor. We can put varying size mufflers on them that will stifle some of the noise. What does it affect? The high end of the torque?
We have a closed circuit system. It's pretty much, we'll have 2 hoses coming off the gun. One will be an inlet, one will be an outlet. And it'll go back to a decent sized air muffler. You lose about 18% of the top end of torque. But basically what we would do is we would do a special calibration and we would just increase the PSI to get you back to where the top end should be.
You would just calibrate it with the muffler on it. It's still accurate to plus or minus 5%. These tools are ISO, the tool and the gauges on the filter regulator are ISO certified in our metrology lab. You control your torque based on air pressure. What we have on here are index sockets with 90 and 45 degree indexes on them. So after we do the initial torque, once we determine what it is, you'll do that on all the bolts, then we'll come back, put the tool back on the nut, make a line on one of the 90 degree indexes. When it goes around 2 indexes, you hit your 180 degrees. To set torque with the gun running but off the nut, we've got a certified torque chart here, and it'll tell you to get 184 foot-pounds, set it the PSI at 12 PSI. That's 184 foot-pounds.
So this was the chassis. Yeah. No. Who's there?
Now we're going to do our 90 degree turn. So we take the ink pen and just find a 90 degree mark on the socket right there. You're there. You've done your 90 degree turn. For the sake of expediency, we're going to do the second 90 degree turn. These sockets are made out of a material called Vascomax. Vascomax is a marriage of metals. It's 15% stronger, 30% harder than carbon steel. These will never break. This is a standard socket. And as you see, when you put it on there, you've got a little wiggle ball. That's what we're trying to prevent. With this socket, we designed it to fit over the 12 points in the flange, so it fits in there perfect. So when you're on it, there's no wobble. There's no way it's going to ever slip off of that socket. And that's how most injuries occur. We cut it down in height so that you can get it under the firewall when you're doing the head bolts. Jeff's done it on all the bolts. It fits. You don't have a height restriction on the mains, but we still do. We want to get it as close on that nut as we possibly can, so it's not going to slip off. And what this is a 12.24 millimeter socket, and this is a reaction cup. It's like 25 millimeters, and it's just designed to fit over the socket, so you don't have to index two of them. You index this one, the other one fits right over. If you have to pull the trigger of the gun to get the socket to turn a quarter turn to get on, that won't hurt it. Torque is Newton's third law of physics. For every action is an equally positive reaction. This is the reaction arm we use for the head bolts, the main bearing bolts. This is the reaction arm we use for lug nuts. And to change that, the reaction arm, simply take an Allen wrench, take that bolt out, put this one back on and bolt it. It takes you about 10 or 15 seconds. We designed this one so it would fit with the curve of the rim on your commercial truck. So you're against the next nut. You could actually do it with this reaction arm. It'll hit the next nut. But we discovered if the mechanic puts the tool in reverse and not forward, and it swings back around, it'll chew up an aluminum rim before he can get his finger off the gun. So this is the safest way to do it. This would be for lug nuts. This would be for leaf spring bolt joints, and for doing the flywheel bolts if you elect to do it like that. We had a customer tell us that they did a study, and we asked them to share it with us, and they won't. So it's an internal document, and they'd have to release safety figures to back it up. They don't want to do that, but they said from a ergonomic standpoint, it pays for itself in 34 days. From a warranty standpoint, it'll pay for itself with time savings in like 19 days. From a safety standpoint, the tool pays for itself the first day you use it. This is a filter regulator lubricator. This filters the inbound air. You put about a drop of oil a minute on the vanes of the air motor, and you control torque based on air. Pull the trigger when the gun stalls, it's done. Don't hit it again.
Okay.
All right,
That's it?
let's flip it over.
Flip it over. In place, same thing.
Same. That's mark right there.
I'm not sure.
You might want to bump it. There you go. You hit it again. Flip it over.
You're all 7 of those.
Wow.
Yeah, the mains be a deal. Still would like to have something that could get the head.
Wow. It's pretty easy.
Man, Rick, you need to work up a sweat.